friends, this is the 12th standard question paper, the board exam, which was held on the 28th of February 2020. The question paper was easy. All the questions taken from the textbook, multiple choice, and everything was very easy. Now we'll start the solution of this question paper. I tried to solve in a simple language. I hope that you will understood the answers of these questions. This is for the 12th standards, but 11th standard student cannot understand. Now let us start. This is the section A. Question number 1 contains the 8 multiple choice type of the questions, each carrying the 2 marks. And the question number 2, 4 sub questions, each carrying the 1 mark. Then the section B, it is the question number 3 to 14. Each carries 2 marks, and a student have to attempt 8 questions. And the question number, that is a section C, question number 15 to 26, each carries 3 marks, and the student have to attempt any 8 out of them. Section D, that is the question number 27 to 34, each carries 4 marks, and the student have to attempt any 5. And the use of the log table and the use of the calculator is not allowed. Now we'll start the solution. Section A, question number 1. Select and write the most appropriate answer from the given alternatives for each question. The first, in triangle ABC, if A is equals to 2, B is equals to 3, and the sine of capital A is equals to 2 upon 3, then the angle B is equals to. This is the solved question from the textbook. Now see this answer of this. That is, by sine rule, A upon sine A is equals to B upon sine B. The value of A is 2 upon sine A, and the value of B is 2 upon sine B. Then substitute the value of sine of A, which is 2 upon 3, and 3 upon sine B. And if we evaluate, then you will get 2 upon 1 into 3 by 2 is equals to 3 upon sine B. And overall sine of B is equals to 1. Sine of B is equals to 1. It means that the measure of that angle is equals to pi by 2. Again, you can see this here also. This is the question, and the answer is, by the sine rule, A upon sine A is equals to B upon sine B is equals to 2 upon sine A is equals to 3 upon sine B. That is a 2 upon 3 is equals to 3 upon sine B, and that is equals to 2 upon 1 into 3 by 2 is equals to 3 upon sine B, and sine B is equals to 1. Therefore, the measure of angle B is equals to pi by 2. It is on the page number 81. Now next question, that is, if A bar is equals to 2i minus j plus 4k and B bar is equals to 2i plus 3j minus k, and c bar is equals to minus 5i plus 2j plus 3k, then find the value of a bar dot in bracket b bar cross c bar. This is the box product. It's very simple question. That is a bar dot in bracket b bar cross c bar is equals to indeterminate 3 minus 1 4 and 2 3 minus 1 minus 5 2 and 3, and if you solve this determinant, then you will get next step. Therefore, the total answer is 110. The answer is 110. Also, you can see this here also. This is the questions. A bar is equals to 2i minus j plus 4k. B bar is equals to 2i plus 3j minus k, and c bar is equals to minus 5i plus 2j plus 3k. Then a bar dot in bracket b bar cross c bar. See this answer. That is on the page number 143. That is a 3 minus 1 4, 2 3 minus 1 minus 5 2 3, and if we evaluate this determinant, you will get the value 110, and which is the option P is the correct one. Now next, the Cartesian equation of the line passing through the point, that is A 4 2 1 and B 2 minus 1 3 is, let's say, a simple question. Page number 81, page number 143, previous questions. That is, we know that the equation of the line passing through the points x1, y1, z1 and x2, y2, z2 is given by x minus x1 upon x2 minus x1, y minus y1 upon y2 minus y1, z minus z1 upon z2 minus z1. So, the equation of the required line is given by the formula. We substitute, that is x minus 4 upon 2 minus 4, y minus 2 upon minus 1 minus 2, and last is z minus 1 upon 3 minus 1. X minus 4 upon minus 2 is equals to y minus 2 upon minus 3 is equals to z minus 1 upon 2, and evaluate this. That is the option C is the correct one. That is x minus 4 upon 3, y minus 2 upon 3, z minus 1 upon minus 2, and hence option C is the correct one. Also, we can see this here. I will repeat here. This is the question. Cartesian equation of the line passing through the point A4 2 1 B 2 minus 1 3. Now let's answer. See this answer. That is, we know that the equation of the line passing through the points x1, y1, z1 and x2, y2, z2 is given by the formula x minus x1 upon x2 minus x1, y minus y1 upon y2 minus y1 is equals to z minus z1 upon z2 minus z1, which is on the page number 169. Substitute the values and then you will get, that is, the equation of the required line is given by x minus 4 upon 2 minus 4, y minus 2 upon minus 1 minus 2 is equals to z minus 1 upon 3 minus 1. That is x minus 4 upon minus 2, y minus 2 upon minus 3, z minus 1 upon 2, and the equation is x minus 4 upon 2, y minus 2 upon 3, z minus 1 upon minus 2. Now the next question is, We'll see this question again. This is the question. The line, if the line r bar is equals to, in bracket, I minus 2j plus 3k plus lambda into 2i plus j plus 2k is a parallel to the plane r bar dot in bracket 3i minus 2j plus mk is equals to 10. Then the value of m is, that is, we want to find out the value of m. Now see this here. The given line is parallel to the vector that is b bar is equals to 2i plus j plus 2k and normal to the given plane is, that is a 3i n bar is equal to 3i minus 2j plus mk. If the line is parallel to the plane, then normal to the plane is perpendicular to the line. That is, b bar is perpendicular to n bar. B bar dot n bar is equals to 0. And if we take their dot product, then we will get the answer. That is a 2 into 3 and 1 into minus 2, 2 into m. That is 6 minus 2 plus 2m is equals to 0. That is 4 plus 2m is equals to 0. That is a m is equals to minus 2. This is the value of, therefore option, that is a is a correct. So it is on the page number 195 and it is a solved question. Now again we'll see the answer of this question. If the line r bar is equals to I minus 2j plus 3k plus lambda in bracket 2i plus j plus 2k is a parallel to the plane r bar dot in bracket 3i minus 2j plus mk is equals to 10, then find the value of m. And see this. The given line is parallel to the vector. This is the solved problem on the page number 195. Parallel to the vector, that is a b bar, and normal to the plane, which is n bar is equals to 3i minus 2j plus mk. If the line is parallel to the plane, then normal to the plane is a perpendicular to the line. Therefore, b bar is a perpendicular to n. B bar dot n bar is equals to 0. And if we take their dot product, then we will get the answer. 2 into 3, 6. 1 into minus 2, minus 2. 2 into m, that is a 2m, plus 2m is equals to 0. And if we evaluate the, that is a 4 plus 2m is equals to 0, 2m is equals to minus 4, m is equals to minus 2. And the value of m is equals to minus 2. Now the next question. That is it. Let's see the question first of all. That is fifth. If f of x is equals to 1 minus x and the value of x lies between 0 and 1 and equal to 1. Equal to k for x is equals to 0 is a continuous at x is equals to 0. This is a question which is solved on the page in the textbook continuity chapter. Then find the value of k. See this here. at x is equals to 0. That is in continuity. The value of the function is equals to the limit of the function. F of 0 is equals to limit x tends to 0 f of x. Limit x tends to 0, 1 minus k, that 1 minus x. As x tends to 0, it becomes 0, that is k is equals to 1. Therefore, the option D is the correct one. Now, again, we will see this answer of this question. See this question, f of x is equals to 1 minus k, x lies between 0 and 1 and equal to 1 and equal to k for x is equals to 0 is a continuous at x is equals to 0. Its answer is, that is the f of 0 is equals to limit x tends to 0, which is on the page number 18. K is equals to limit x tends to 0, 1 minus x. The value of k is equals to 1. Therefore, the option D is a correct one. Now, the next is the function f of x is equals to x raised to x is a minimum at which value? This is the question. See this answer. Y is equals to x raised to x is from the application of the derivative. That is f of x is equals to y is equals to x raised to x. Take log on both sides. Then you will get log of y is equals to x into log of x. And find out the first derivative, second derivative. Now differentiate with respect to x. The derivative of log of y is 1 upon y into dy by dx. And x into log of x. It is by the product rule. That is x into derivative of log of x is 1 upon x plus log of x as it is, the derivative of x is 1. That is the only the log of 1 into log of x. Therefore, 1 upon dy by dx is equals to y into, in bracket, 1 plus log of x. Therefore, dy by dx is equals to x raised to x, in bracket 1 plus log of x. Now, that is the f dash of x is equals to 0 for the first derivative test. F of x is equals to 0, x raised to x in bracket 1 plus log of x is equals to 0. It means that x raised to x is not equals to 0. 1 plus x raised to x is equals to 0. Then what is the value of x? That is log of x is equals to minus 1. Then this is the logarithmic. We can convert it into the exponential and it becomes x is equals to e raised to minus 1. That is x is equals to 1 upon e. F dash of x is equals to x into, that is f dash of x is equals to x raised to x in bracket 1 plus log of x. F double dash of x is equals to x raised to x and derivative of 1 plus log of x. The derivative of 1 is 0, log of x is 1 upon x. And the next is 1 plus log of x and derivative of x raised to x. That is the derivative of x raised to x is in, that is x raised to x in bracket 1 plus log of x. And if you substitute the value, that is x is equals to 1 upon e, then this will be the positive, which is a greater than 0. Hence, by the second derivative test, that is, it is minimum. X raised to x is a minimum at x is equals to 1 upon e. This is the unsolved question. It's a given in the textbook in the form of, that is a prove that it is a given function is a minimum at that point, which is the x is equals to 1 upon e. Now, next is again we will see this answer. X f of x is equals to x raised to x is a minimum at x is equals to 0. Its a solution is again y is equals to x raised to x, f of x is equals to y is equals to x raised to x. Unsolved question on the page number 116. Take log on both sides. Log of y is equals to x into log of x. differentiate with respect to x. Therefore, 1 upon y into dy by dx is equals to x into log of x. Derivative of log of x is 1 upon x plus 1 into log of x. And that is, you will get dy by dx is equals to y into in bracket 1 plus log of x. Therefore, f dash of x is equals to dy by dx is equals to x raised to x in bracket 1 plus log of x. And that's why that is f dash of x is equals to 0 is equals to x raised to x in bracket 1 plus log of x. It means that 1 plus log of x is equals to 0, log of x is equals to minus 1, and this logarithmic function can be converted into the exponential, that is x is equals to e raised to minus 1. Therefore, x is equals to 1 upon e. Therefore, f dash of x is equals to x raised to x in bracket 1 plus log of x. Now find out the second derivative. Therefore, the f double dash of x is equals to x raised to x in bracket. Keep this as it is. Derivative of 1 plus log of x is derivative of 1 is 0, log of x is 1 upon x plus 1 plus log of x and derivative of x raised to x. That is x raised to x in bracket 1 plus log of x. And if we substitute that x is equals to 1 upon e, overall it is a positive. And hence the given function is a minimum at x is equals to 1 upon e. Now the next question is, now the question number 7. If integral 0 to k 4x cubed dx is equals to 16, then find the value of k. Normal integration is there. Zero to k 4x cubed into dx, that is equals to 16. The integration of 4x cubed, that is a 4x raised to 4 upon 4, and the upper limit is k and lower limit is 0. We substitute 0 to k is equals to 16. That is a x raised to 4. Lower limit is 0, upper limit is k, that is equals to 16. Therefore, k raised to 16 is equals to k raised to 4 is equals to 16. Therefore, that is equals to 2 raised to 4, and therefore k is equals to 2. It's also unsolved question on the page number 201. Now see this again here. The question is integral 0 to k 4x cubed into dx is equals to 16. Then find the value of k. Normal integration is there. Answer 0 to k 4x cubed into dx is equals to 16. 4x raised to 4 upon 4, 0 to k is equals to 16. X raised to 4, 0 to k, that is equals to 16. K raised to 4 minus 0, that is equals to 16. K raised to 4, 16 means what? 2 raised to 4, and hence the k is equals to 2. And that's why the option B is a correct one. Now the next question. The given differential equation is of the order 4n. Now see this, the differential equation. Order and the degree of differential equation. That is the highest order is a d4y upon dx raised to 4. In square bracket, that is a 1 plus dy by dx bracket square and bracket raised to 3. But what is the highest order? The highest order is the d4y upon dx raised to 4. Therefore, its exponent is 1. Therefore, order is 4 and degree is 1. And that's why option B is a correct one. Order is 4 and degree is 1. It is also from the textbook. Question number. Now question number 2. Answer the following questions. The first question is the dual of P and negation of P equivalents to F. Now to find out the dual, that is and is replaced by or and f is replaced by t. Therefore, p or negation of p is equivalent to t. Next is find the general solution of tan of 2x. Now we'll see the general solution of the tan of 2x. General solution of the tan of 2x, that is equals to 0. Tan theta is equals to 0. It implies that theta is equals to n pi where n belongs to z, which is the set of integers. Now here in place of the theta here, tan of 2x is equals to 0. Therefore 2x is equals to n pi and therefore x is equals to n pi upon 2. Where n belongs to set of integers, therefore tan of 2x is equals to 0. Then the general solution is equal, that is x is equals to n pi upon 2, where n belongs to set of integers. This is also a question from the page number 73. Now see this again. It's a solution. The dual of p and negation of p equals to f. That is a p or negation of p is equivalent to, that is a t. I forget to write out again one more line there. The general solution of tan of 2x is equals to 0. Tan theta is equals to 0 implies that theta is equals to n pi where n belongs to set of integers, and tan of 2x is equals to 0. That is a 2x is equals to n pi where x is equals to n pi upon 2 and n belongs to a set of integers. It is on the page number 73. Now the next question is that the sign in bracket x square plus x differentiate with respect to x. I had written here u is equals to and v is equals to. Instead of that, you can differentiate this with respect to x also. Now see this here. I had written in the two form, that is u and v. It is not necessary, but okay. That u is equals to sine in bracket x square plus x and v is equals to x. Now differentiate this u with respect to x, and the derivative of sine of x is a cos of x square plus x into derivative of x square plus x, and the derivative of x square plus x is a 2x plus 1. Now see this here. Du by dx, derivative of sine of x square plus x is a cos of x square plus x into ddx of x square plus x. The derivative of x square is a 2x and the derivative of x is 1. Therefore 2 in bracket 2x plus 1 cos of x square plus x. This is the first one. And the derivative of u, v is equals to x, differentiate with respect to x, dv by dx is 1. Therefore from 1 and 2, that is a u with respect to v, that is a du by dv is equals to du by dx upon dv by dx. Instead of directly you can differentiate with respect to x. First I had done like this, that is a 2x plus 1 into cos of x square plus x upon 1, that is a du by dx is equals to in bracket 2x plus 1 into cos of x square plus x. Therefore du upon dv is equals to 2x plus 1 into cos of x square plus x. Now the next, also you can see this like that. So that u is equals to and v is equals to differentiate u and v with respect to x, du by dx. It's a derivative. The derivative of that is the derivative of sine of x square plus x is the cos of x square plus x into ddx of x square plus x, which is the 2x plus 1, and the derivative of x is 1, and that's why you will have from 1 and 2 du by dv is equals to du by dx upon dv by dx 2x plus 1 into cos of x square plus x. Instead of this we can differentiate directly also. Okay. The question number 4 is that if x follows the binomial distribution, if x follows the binomial distribution. N is equals to 10. Expected value of x is 5. Then find the value of p. Very simple question. X follows the binomial distribution. N is equals to 10. E of x is equals to 5. We have given that n is equals to 10. E of x is equals to 5. E of x is equals to np. Substitute the value. 5 is equals to 10 into p. P is equals to 1 upon 2. Therefore, p is equals to 1 upon 2. That is, it is on the page number 341. Unsolved question. Now again, see this here. This is the x follows the binomial distribution. N is equals to 10. E of x is equals to 5. Then find the value of p. The answer is n is equals to 10. E of x is equals to 5. E of x is equals to np. 5 is equals to 10 into p. P is equals to 1 upon 2. Unsolved question on the page number 341. Now the next is section B. The first question, that is a question number 3. Using the truth table, verify that negation of P or Q is equivalent to negation of P and negation of Q. Very simple question. That is, a P is written as double T double F and Q is written as TF TF. Then we'll find out the negation of P, negation of Q, their OR and their AND. Then negation of P, negation of Q. That is, negation of P means what? That is a T. Negation of T is F. T is F. F is T. F is T. Negation of Q. T is F. F is T. T is F. F is T. And then we will form this statement now. P or Q. Now see this here. P or Q. What statement tells the P or Q? If one of them is true, then it is true. Otherwise false. That is, a TT is T. TF is T. FT is T. But FF is F. See this here. Now next, negation of P or Q. That is the negation of this column. That is F, 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 and this is the T. See this here. Okay. Now we'll form this statement. That is the negation of P and negation of Q. For the AND statement, if both of them is true, then it is true. Otherwise, it is a false. Therefore, here is a F, 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 and only here you will be the T there. Now see this here. F, 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 and T. Now if you see, that is the column number 6 and 7 both are the equivalent, and hence it is a proof. Now then, let's see this again here. Using the table, column 6 and 7 both are equal, and hence it is a proof. That is a P double T double F Q T F T F, negation of P, negation of Q, or P or Q, and the negation of P or Q, and the last is negation of P and negation of Q. Now, the 6 and 7 both are the equal. Now, let's see the next question. Find the matrix of cofactors for the matrix 1, 3, 4, -1, Now here a11 is 1 and it's a minor now. It's a minor is a -1. Then we'll find out its a cofactor. We'll find out it's a minor. That is a11 is equals to -1 raised to 1 plus 1 m11. That is a11 is -1. Next is a12. a12 that is equals to 3. m12 is 4. And cofactor a12 is equals to -1 raised to 1 plus 2 and m12. But the value of m12 is 4. -1 into 4, that is a -4. Therefore, a12 is equals to -4. Then a21 that is equals to 4. Therefore, its minor is 3. And a21 is equals to -1 raised to 2 plus 1 into m21, that is -1 into 3, that is equals to -3. And last is a22. The element a22 is -1, m22 is 1, and a22 is a -1 raised to 2 plus 2 into m22, and hence it is again 1. And therefore, the cofactor matrix is a11, a12, a21, a22, that is a -1, -4, -3 and 1. And hence the cofactor matrix. Now let us see this here. Find the cofactor matrix. This is the first element. Then how to find out the minor? See this in horizontal and the vertical. Which element is there? -1 is there. Therefore, the m11 is a -1. It's a cofactor a11. -1 raised to 1 plus 1. m11, and overall you will get -1. a12, second element. This is a 3. It's a minor, is 4. And a12 -1 raised to 1 plus 2, m12 -1 into 4, that is -4. a12 is -4. a21, that is equals to 4. m21 is equals to 3. a21, that is a -1 raised to 2 plus 1, m21 -1 into 3, that is equals to -3. a22, it is a -1, and that's why m22 is its a minor is 1. Its a cofactor is a22 -1 raised to 2 plus 2 m22, and that is equals to 1. Therefore, the cofactor matrix a11, a12, a21, a22, that is a -1, -4, -3, 1. And this is the final answer. Now, next is find the angle between the lines represented by 3x square plus 4xy minus 3y square is equals to. This question is from the straight line. It's very simple question. Now to find out the angle between the lines represented by 3x square plus 4xy minus 3y square is equals to 0. This is the joint equation of pair of two straight line which passes through the origin. Its a standard form is ax square plus 2hxy plus by square is equals to 0. The value of a is 3 and the value of h is 2 and the value of b is -3. But here it's clear that a plus b is equals to 0 and hence the given lines are perpendicular to each other. Now see the function. Find the angle between the lines represented by 3x square plus 4xy minus 3y square is equals to 0. Comparing with ax square plus 2hxy plus by square is equals to 0. A is 3, h is 2, b is -3. But there is one more condition that when the lines perpendicular, then a plus b is equals to 0. That is the coefficient of x square plus coefficient of y square. is equals to 0, then the lines are perpendicular. Therefore, theta is equals to 90 degree. We will again see this here. The answer of this question. Comparing with the value of a plus b is equals to 0. The lines are perpendicular. Yes, on the page number 122. Now the next question. That is, a bar and b bar are non-collinear vectors if the c bar is equals to in bracket x minus 2 into a bar plus b bar and d bar is equals to 2x plus 1, a bar minus b bar are the collinear. This c bar and d bar are the collinear. Then find the value of x. Also it is from the textbook, page number 137. That is, c bar and d bar are the collinear vectors. When the two vectors are collinear, one vector can be expressed as a scalar multiple of the other vector. That is, there is a scalar t such that c bar is equals to 2 into d bar. X minus 2 into a bar plus b bar is equals to t in bracket 2x plus 1 into a bar minus b bar. Now from their multiplication, that is x minus 2 a bar plus b bar is equals to 2t in bracket 2x plus 1 into a bar minus tb bar. Compare the coefficients of a bar and b bar. Therefore, you will get x minus 2 is equals to t in bracket 2x plus 1. T in bracket 2x plus 1 and 1 is equals to minus t. That is, a t is equals to minus 1, x minus 2. The value of t is a minus 1 and evaluate this. That is, a 2x minus 1 is equals to t in bracket 2x plus 1. X minus 2 is equals to t in bracket 2x plus 1. X minus 2 is equals to minus, substitute the value of t, minus 1 in bracket 2x plus 1. That is, x minus 2 is equals to minus 2x plus 1. Therefore, you will get 3x is equals to 1 and that is x is equals to 1 upon 3. Let's see this again. The answer of this question. Since the c bar and the d bar are the collinear vectors, it's the answer question from the page number 137. C bar is equals to t into d bar. X minus c bar is equals to t into d bar, that is x minus 2 bracket complete a bar plus b bar is equals to t in bracket 2x plus 1 a bar minus b bar. And evaluate these. Compare the coefficients of a bar and b bar. That's why you will get the value of the t is equals to minus 1. Substitute the value of the t here. Then you will get the value of x, which is equals to 1 upon, that is x is equals to 1 upon 3. This is the final answer. Answer question, page number. Now the next is, if a line makes an angle of 90 degree, 135 degree, 45 degree with the x, y and the z axis respectively, then find its direction cosines. It's on the page number 159 from the M1. See this answer. Very simple question. That is question number 7. L, M and R the direction cosines of the line. Then L is equals to cos alpha, M is equals to cos beta, N is equals to cos of gamma. Here alpha is equals to 90 degree, beta is equals to 135, gamma is equals to 45. L is equals to cos 90, M is equals to cos of 135 and gamma is equals to 45. Therefore, now see this here, cos of 90 is 0, it's there, and M is equals to cos of beta, that is equals to 135, and the cos of 90 plus 45, That is cos of 90 plus 45. Whenever there is a pi by 2 plus theta, it becomes, that is a function changes. That is a cos becomes sine, sine becomes cos. But now this is in the second quadrant, it has the negative sign. That is a minus sine of 45, and the sine 45 is a minus m is equals to minus 1 upon root 2 n is equals to cos of 45, it is again 1 by root 2. Therefore, the direction cosines of the line are 0, minus 1 by root 2 and plus 1 by root 2. These are the on the page number 159 unsolved question. Now see this again, we'll see the solution. That is element are the direction cosines of the line. Then L is equals to cos alpha, M is equals to cos of beta, N is equals to cos of gamma. Alpha is 90, beta is 135, gamma is 45. L is equals to 90 degree. M is equals to, that is a cos of beta 135, 90 plus 45, and that is a minus sine of 45. Therefore, M is equals to minus 1 by root 2, and the cos of the N is equals to cos of gamma, which is again 1 upon root 2, and therefore the direction cosines of the line are 0, minus 1 by root 2 and plus 1 by root 2. Now see the next question. Express the following circuit in the symbolic form. So this is on the page number 29, and it is a solved question, solved example on the page number 29. That is, we will see the question again. This is the question. That is, see this here, S1, S2 and S3. S1 is a parallel with S2 and S3. These two are parallel. S2 and S3 are in series. Now we'll construct here. Let P, the switch S1 is a closed, Q, the switch S2 is a closed, and R, the switch S3 is a closed. By symbolic, that is a symbolic form of the given circuit is, that is S1 is a parallel to S2 and S3, that is a P, or in bracket Q and R, and that is equals to L. Now the next question is that differentiate, that is a log of sec x plus tan x with respect to x. Very simple differentiation is there. The derivative of log of x is 1 upon x, that is y is equals to log of sec x plus tan x. Differentiate with respect to x. Therefore, you will get dy by dx is equals to 1 upon sec x plus tan x into ddx of sec x plus tan x. Therefore, 1 upon sec x plus tan x into derivative of sec x is sec x into tan x plus tan square x. Take sec x as a common. Then you will get tan x plus sec x. Now tan x plus sec x get cancelled. And dy by dx is equals to sec x plus tan x. Also, you see here answer of this question. The previous one is also, that is switch S1 is a closed, Q switch S2 is a closed, R the switch S3 is a closed, symbolic representation P or in bracket Q and R. Now the next is y is equals to log of sec x plus tan x, differentiate with respect to x. Therefore, dy by dx is equals to 1 upon in bracket sec x plus tan x into ddx of sec x plus tan x. 1 upon sec x plus tan x into derivative of sec x is sec x into tan x plus the derivative of tan x is the sec square x. Now we can take the common from these two, sec x and that's why in bracket you will get sec x plus tan x, and from the numerator and denominator these two terms are same, therefore you will get dy by dx is equals to sec x. Now the next is evaluate. Question number 10, evaluate from the integration. That is a dx upon x square plus 4x plus z. Very simple integration. Here is, see this, I is equals to integral dx upon x square plus 4x plus 8. Now express in the quadratic form, x square plus 2 into 2x plus 4 plus 4. That is, you will get dx upon x square plus 4x. That is a 2 into x. 2. That is a dx upon x plus 2 bracket square plus 2 square. And this is of the form, that is 1 upon a tan inverse of x upon a. A is here 2. Therefore, it is a 1 upon a tan inverse of x upon a. What is x here? That is a x plus 2 upon a, which is 2, plus c. Therefore, the integration is 1 upon 2 into tan inverse of x plus 2 upon 2 plus c. It is on the page number 141 and it's a solved question. Now, see this again. That is a I is equals to integral dx upon x square plus 4x plus 8. X square plus 2 into x plus 4 plus 4. That is, it can be written as. Now, this is a perfect square. That is x plus 2 bracket square plus 2 square. That is integral dx upon x plus 2 bracket square plus 2 square. Therefore, its integration is nothing but it is of the form. That is integral dx upon x square plus x square, which is nothing but 1 upon a tan inverse of x upon a. It is of the form 1 upon a is here 2. Tan inverse of x is x plus 2 upon a is 2 plus c. Now, let's see the next question. Now, the question number 11, that is evaluate the integral 0 to pi by 2 cos square x into d. Very simple example. And also it is a solved question. You cannot directly integrate cos square. That's by using the formula. What is the cos square x? That is 1 plus cos of 2x upon 2. By using that formula, you will integrate it. See this here. Unsolved question, sorry. And the page number 200. I is equals to integral 0 to pi by 2 cos square x into dx. 1 plus cos of 2x upon 2 into, not the square, that is the, therefore separate it, 1 upon 2 common, in bracket 1 upon 2, 0 to pi by 2, 1 plus cos of 2x into dx. Integral of 1 is x and cos of 2x is the sine of 2x upon 2. See this here, x plus sine of 2x upon 2, 0 to pi by 2. Substitute the value of this x, which is pi by 2, plus sine of 2 into pi by 2 upon 2, and the next minus 0. Replace x by 0, that is x is replaced by 0, sine of 0 upon 2. Now this is 0, sine 0 is 0. Then what you will get? This 2 will get cancelled, that is the sine of pi, and sine pi is 0, 0 upon 2, which is overall it is 0. That is 1 upon 2 into pi by 2. Therefore, you will get the answer pi by 4. That is equals to pi by 4. Therefore, the I is equals to pi by 4. Again, you can see this answer. That is I is equals to integral 0 to pi by 2 cos square x into dx. That is the 0 to pi by 2 cos square x. The formula for the cos square x is 1 plus cos of 2x upon 2 into dx. Take 1 upon 2 as common in bracket 1 plus cos of 2x. Integral of 1 is x. Cos of 2x means what? It's a sine of 2x upon the derivative of 2x is 2. That is 0 to pi by 2. And Substitute the value of the pi by 2 upper limit minus lower limit. Then you will get 1 upon 2 in bracket pi by 2 plus sine of this pi upon 2 minus this 0 and sine of pi is 0. Therefore 1 upon 2 in bracket pi by 2 plus 0 and overall you will get pi by 4. It is on page number 200. Solve the question. Now the next question is, that is, solve the differential equation dy by dx is equals to x square into y plus 1. Solve the differential equation dy by dx is equals to x square into y plus 1. Now we'll solve this equation. Dy by dx is equals to x square into y plus y. Dy by dx y in bracket x square plus 1. Dy by dx, that is equals to y in bracket x square plus 1. Dy is equals to y into in bracket x square plus 1 into dx. Separate the variable form, that is dy upon y and x square plus 1 into dx. Integrate on both sides. That integral dy upon y is equals to integral in bracket x square plus 1 into dx plus c. And integral of dy upon y is a log of y. And integral of x square is x cube upon 3. And the integral of x is 1 is x plus c. See this here. That is log of y is equals to x cube upon 3 plus x plus c. Log of mod of y is equals to x cube upon 3 plus x plus c. This is the general solution. It is on the page number 263, unsolved question. You can see this also here. That is the dy by dx is equals to x square into y plus 1. Dy by dx, y in bracket x square plus 1. Take y as common, then in bracket you will get x square plus 1 into dx. Dy upon y is equals to x square plus 1 into dx. Integrating on both sides, then you will get integral dy upon y is equals to in bracket x square plus 1 into dx plus c. Log of y is equals to x cube upon 3 plus x plus c. Log of mod of y is equals to x cube upon 3 plus x plus c. There, this is the general solution. Now we'll see the next question. Find the expected value of the random variable capital X whose the probability mass function is given. That is, capital X is equals to the small x and its value is 1, 2, 3. And the P of X, P of capital X is equals to small x, its value is 1 by 5, 2 by 5, 2 by 5. It's on the page number 327, miscellaneous unsolved question. Now we'll see the answer. Question number 13. We construct the following table to find the expected value xy, which is 1, 2, 3, p of xi into pi. Substitute their values. Xi, the values of xi is 1, 2, 3. Value of p of xi, which is 1 by 5, 2 by 5, and the 2 by 5. And they are now their product. See their product. 1 by 5, 2 into, that is 4 by 5, 6 by 5. F, their sum total 1 by 5 plus 2 by 5 plus 2 by 5, that is 1. And next is 11 by 5. Their expected value of that E of x is equals to summation xi into P of xi, which is 11 by 5. It is on the page number 327, miscellaneous unsolved question. You can see this here. We construct the table xi, P of xi, xi into pi, their products is given. Unsolved miscellaneous exercise. Expected value, that is e of x is equals to summation xi into p of xi, and that is nothing but the 11 upon 5. Now see this next question. That is, see this here again the question. I will keep it here. That is question number 14. If y is equals to x into log of x, then find d2y by dx square. It is on the page number 78 and it is a solved question. Very simple question. Question number 14. Y is equals to x log x. Then find d2y by dx square. Y is equals to x into log of x. Differentiate with respect to x. dy by dx is equals to x into log of x by using the product rule. The derivative of log of x is 1 upon x, x into 1 upon x plus 1 into log of x, that is 1 plus the log of x. This is the dy by dx. Now we want to find out second derivative, that is again d2y by dx square. The derivative of 1 is x, 1 is 0 and the log of x is 1 upon x. Therefore, d2y by dx square is equals to 1 upon x. It is on the page number 78. Solved question is there. Now see this again, the solution. Y is equals to x log x, and find d2y by dx square. Y is equals to x log of x, differentiate with respect to x. dy by dx is equals to x into 1 upon x plus 1 into log of x. Therefore, dy by dx is equals to 1 plus log of x, differentiate with respect to x. Again, that is a d2y by dx square, derivative of 1 is 0, log of x is 1 upon x. Therefore, d2y by dx square is equals to 1 upon x. Now the next is, now the section C. Attempt any 8 of the following questions. Question number 15. State the converse, inverse and the contrapositive of the conditional statement. If a sequence is bounded, then it is a convergent. Now, it is on page number 13, unsolved question. If a sequence is bounded, then it is convergent. Let P, a sequence, is bounded. Q, it is a convergent. Then the symbolic form of the given statement is, that is a P implies Q. The sequence is bounded, then it is a convergent, which is a P implies Q. Now it's a converse. What is that converse? That is Q implies P. Therefore, it is a converse of P implies Q. That is, if the sequence is convergent, then it is a bounded. This is the converse. Inverse, that is the negation of the given statement. Negation of P implies negation of Q. It's very simple to remember the converse. That is the inverse of P implies Q. If the sequence is not bounded, then it is not convergent. It's clear. This is the inverse. And next is the contrapositive. Contrapositive is nothing but the negation of the converse. That is, the negation of Q implies negation of P. Is the contrapositive of P implies Q. That is, if the sequence is not convergent, then it is not bounded. Therefore, now see this again. If the sequence is not bounded, then it is a convergent. P, a sequence is bounded. Q, sequence is convergent. It is on the page number 13 unsolved question. Then symbolic form, that is the P implies Q. The converse means what? Q implies P. Is the converse of the P implies Q. If a sequence is convergent, then it is a bounded. Inverse, that is the negation of P implies negation of Q. It's the inverse of P implies Q. That is, it is a sequence. If the sequence is not bounded, then it is not convergent. And the next is a contrapositive. That is the negation of Q implies negation of P is the contrapositive of the P implies Q. If a sequence is not convergent, then it is not bounded. Now the next is say this here. That is sin inverse of 8 upon 17 plus sin inverse of 3 upon 5 is equals to sin inverse of 77 upon 85 is on the page number 112 from the miscellaneous question. Now see this here. Question number 16. Sin of 8 upon 17 that is equals to x. Sin inverse of 3 upon 5 that is equals to y. Sin inverse of 8 upon 17. I forgot to write here inverse sign. That is, and the next is a sin inverse of 77 upon 85 that is equals to z. Now here, therefore, the sin x is equals to 8 upon 70. Next is a sin of y is equals to 3 upon 5 and sin of z is equals to 77 upon 85. Now here the value of x is lies between 0 to pi by 2. Y is also 0 to pi by 2 and z is also 0 to pi by 2. All are being positive. Now the cos of x is a positive, cos of x is positive, cos of y is also positive here. Now what's happening? That is the cos of x is equals to in under root of 1 minus sin square x. That is in under root of 1 minus, that is 84 upon 289. That is a 225 upon 289. That is 15 upon 70. This is the cos x. And which is the positive. Cos of y is 1 minus sin square y. That is a 9 upon 25. That is a 16 upon 25, which is equals to 4 upon 5. Therefore, cos of y is equals to 4 upon 5. We have to show that x plus y is equals to z. That is, sin of x plus y is equals to sin x into cos y plus cos x into sin of y and substitute their values. That is 8 upon 17 into 4 upon 5 plus 15 upon 17 into 3 upon 5. And if you evaluate, then you will get 32 upon 85 plus 45 upon 85. That is 77 upon 85. That is sin of x plus y is equals to sin of z. Therefore, x plus y is equals to z. And hence sin inverse of 8 upon 17 plus sin inverse of 3 by 5 is equals to sin inverse of 77 upon 85. And this is on the page number 112. Now again we'll see here. Page number 112. Answered question from the miscellaneous. Sin inverse. Sin inverse of 8 upon 17 is equals to x. Sin inverse of 3 by 5 is equals to y. Sin inverse of 77 upon 85 is equals to z. I forget to write here inverse sign here. Therefore, sin of x is equals to 8 upon 17. Sin of y is equals to 3 by 5. And sin z is equals to 77 upon 85. The values of x, y, z lies between 0 to pi by 2. Cos x and cos y is also positive. Now cos x is equals to in under root of 1 minus sin square x. That is a 1 minus 64 upon 289. That is a 2 25 upon 289, 15 upon 17. Therefore, cos x is equals to 15 upon 17. Next is cos of y is equals to in under root of 1 minus sin square y. That is in under root of 1 minus 9 upon 25. That is a 16 upon 25. That is equals to 4 upon 5. Therefore, cos of y is equals to 4 upon 5. We have to show that x plus y is equals to z. Now, sin of x plus y is equals to sin x into cos y plus cos x into sin y. Substitute the values, then you will get, that is a 8 upon 17 into 4 upon 5 plus 15 upon 17 into 3 upon 5. That is 32 upon 85 plus 45 upon 85. And overall you will get 77 upon 85. Therefore, sin of x plus y is equals to sin z, and that is a x plus y is equals to z. Hence, the sin inverse of 8 upon 17 plus sin inverse of 3 by 5 is equals to sin inverse of 77 upon 85, and hence it is a proof. Now the next question. Question number 17. No, before that we will see the question. That is, show that the point A 2 1 minus 1, B 0 minus 1 0, and C 4 0 4 and D 2 0 1 are the coplanar. See this answer. It is on the page number 144. The position vectors A bar, B bar, C bar and the D bar of the points A, B, C and D with respect to origin. A bar is equals to 2i plus j minus k, B bar is equals to minus j, C bar is equals to 4i plus 4k, and D bar is equals to 2i plus k. Now AB bar, that is B bar minus A bar, that is minus j in bracket, minus in bracket 2i plus j minus k, and overall you will get, that is a minus 2i minus 2j minus k, that is a plus k, sorry, minus minus will become plus. AC bar, C bar minus A bar, that is a 4i plus 4k minus in bracket 2i plus j minus k. Evaluate this, that is a 2i minus j plus 5k. A is common here, AB, AC, AD. D bar minus A bar, that is a 2i plus k minus in bracket 2i plus j minus k, and evaluate this, then you will get minus j plus 2k. Now we will form their box product, that is AB bar, AC bar and AD bar. That is a 2 minus 2 1, 2 minus 1 5, 0 1 2, and evaluate it. It's a simple determinant. That is equals to 0, and hence the given points are the coplanar. A bar, B bar, C bar, AB bar, AC bar, AD bar are the coplanar, and they have the points A in common. Therefore, the points A, B, C, D are coplanar. It is on the page number 144. Now, see this again here. These are the points A bar, B bar, C bar, then AB bar, AC bar, A bar, B bar, C bar, D bar. From the AB bar, B bar minus A bar, AC bar, C bar minus A bar. See this here. AD bar, D bar minus A bar, and their box product. That is AB bar, AC bar, AD bar. That is a minus 2, minus 2 1, 2 minus 1 5, 0 minus 1 2, and that's why you will get the value of the determinant that is equals to 0, and AB bar, AC bar, AD bar are the coplanar. They have the point A in the common, therefore the points A, B, C, D are the coplanar. Now the next is next question is, that is if the triangle ABC is a right angle at B, where A is a 5, 6, 4, B is a 4, 4, 1, and C is a 8, 2, X, then find the value of X. Now, see this here. Question number 18. The direction ratios of the side AB are A1 is 4 minus 5, that is minus 1. B1 is 4 minus 6, that is a minus 2. And C1 is 1 minus 4, that is equals to minus 3. A2. Direction ratios of side BC are A2, 8 minus 4, that is 4. B2, 2 minus 4, that is equals to minus 2. C2, X minus 1. Since the triangle ABC is a right angle at the point B, AB is perpendicular to side BC. B is a common. A1 into A2 plus B1 into B2 plus C1 into C2 is equals to 0. Minus 1 into 4 plus minus 2 into minus 2 plus minus 3 into X minus 1, that is equals to 0. Now evaluate this. Minus 4 plus 4 minus 3x plus 3 is equals to 0. Therefore minus 3x plus 3 is equals to 0. Minus 3x is equals to minus 3. And therefore x is equals to minus 3 upon minus 3, that is x is equals to 1. It is on the page number 163. Unsolved question. Now see this 7 here. The direction ratios of the side AB are, that is subtract the points of the B from A, that is A1 4 minus 5 minus 1, B1 4 minus 6, that is equals to minus 2, C1 1 minus 4, that is equals to minus 3. Direction ratios of the side BC are A2 8 minus 4 is equals to 4, B2 2 minus 4, that is equals to minus 2, and C2 X minus 1. Since the triangle ABC is a right angle at the B, the side AB is a perpendicular to side BC. A1 into A2 plus B1 into B2 plus C1 into C2 is equals to 0. Make their product. Minus 1 into 4 plus minus 2 into minus 2 plus minus 3 into X minus 1, that is equals to 0. Plus minus 4 plus 4 minus 3x plus 3, that is equals to 0. Minus 3x plus 3 is equals to 0. That is a minus 3x is equals to minus 3. And that's why x is equals to 1. The value of x is 1. Now the next question. Next is question number 19. Find the equation of the line passing through the point 3, 1, 2 and perpendicular to the line x minus 1 upon 1, y minus 2 upon 2, z minus 3 upon 3 and x upon minus 3, y upon 2, z upon 5. This is on the page number 181. A is 3, 1, 2. A, B, C be the direction ratios of the required line which is perpendicular to the lines x minus 1 upon 1, y minus 2 upon 2, z minus 3 upon 3 and x upon minus 3, y upon 2, z upon 5. And that's why you will get the equation like this. This is the a into 1a, b into 2, that is a 2b, c into 3, that is a 3c is equals to 0. And the second equation will be minus 2a plus 2b plus 5c, and that is equals to 0. Now solve these two equations. A upon 2, 3, 2, 5 is determinant form. This is a upon 2, 3, 2, 5. Other than a, we take the point here. Equals to, the middle one is always minus, that is a minus b upon, that is the coefficient of a and c, 1, 3, 1, 3. Minus 3, 5. Minus 3, 5 will be there. See this here. And the last is c upon, that is the coefficient of a and b, that is 1, 2, minus 3, 2. See this here. And evaluate it. A upon 10 minus 6 minus b upon 5 plus 9. C upon 2 plus 6. A upon 4 minus b upon 13. C upon 8. That is the direction ratios of the required line are 4 minus 14, 8. That is a 2 minus 7, 4. And therefore, the equation of the line passing through the point 3, 1, 2. X1, Y1, Z1. That is a 3, 1, 2. And having the direction ratios 2 minus 7. That is ABC. X minus X1 upon E. Y minus Y1 upon B. Z minus Z1 upon C. Substitute the values. Therefore, you will get 3, 1, 2. And having the direction ratios 2 minus 7, 4. X minus 3 upon 2. Y minus 1 upon minus 7. Z minus 2 upon 4. Z minus 2 upon 4. This is the equation of the line. Now see this again here. This is the point A, 3, 1, 2. ABC are the direction ratios of the required line perpendicular to this line. Therefore, the equation is A plus 2B plus 3C minus 3A plus 2B plus 5C is equals to 0. The value of A other than the A, that is a B and C, 2, 3, 2, 3, 2, 5, 2, 5. Middle one is a minus B other than B, that is A and C, 1, 3, minus 3, 5. And for the C, which is 1, 2, minus 3 and 2. And evaluate this. You will get the value of, that is a ABCR, that is a 2, minus 7, 4. These are the values of ABC. Therefore, the equation of a line passing through the point x1, y1, z1 and having the direction ratios ABC is x minus x1 upon E, y minus y1 upon B, z minus z1 upon C. The equation of the required line passing through the point 3, 1, 2 and having the direction ratios 2, minus 7, 4 is x minus 3 upon 2, y minus 1 upon minus 7, z minus 2 upon 4. This is the required equation. Now the next is find the distance of the point. See this again here. We'll see the question. Find the distance of the point I plus 2j minus k from the plane r bar dot in bracket I minus 2j plus 4k, that is equals to 10. So this answer. So the distance of the point I plus 2j minus k from the plane r bar dot in bracket I minus 2j plus 4k is equals to 10. The distance of the point A from plane r bar dot n bar is equals to p is given by, that is a d is equals to in mod of a bar dot n bar minus p upon mod of n bar. Now here a bar is, that is the I plus 2j minus k, and the b bar is, that is the n bar is I minus 2j plus 4k, and p is a 10. A bar dot n bar, that is equals to I plus 2j minus k dot I minus 2j plus 4k, from their dot product 1 dot 1, 2 dot minus 2 plus minus 1 dot 4, and that is equals to minus 7. That is the mod of 7, mod of n bar is equals to, that is in mod of, that is a 1 square minus 2 square plus 4 square, that is equals to 1 plus 4 plus 16, which is equals to 21. Therefore, the required distance, that is equals to minus 7 minus 10 upon root of 21. That is a 17 upon root of 21. This is the question on the page number 199. Now see this again here, answer. Page number 199. The distance of the point from this plane r bar dot n bar is equals to p is given by the formula. Distance of this point from this plane, that is, will require the values. Which are the values? Will require the a, n, the value of p, and mod of n bar. What is n here? N is a I minus 2j plus 4k. Substitute the value. That is a is, which is the given, that is a 1 plus 2j minus k. N is here 1 minus 2j plus 4k. And what about the p? P is 10. Therefore, a bar dot n bar. Find out the value of a bar dot n bar. That is I plus 2j minus k dot in bracket I minus 2j plus 4k. From there dot 1 dot 1 plus 2 dot minus 2 plus minus 1 into 4. And overall you will get minus 7. Mod of n bar is equals to in under root of 1 square minus 2 square plus 4 square. That is in under root of 1 plus 4 plus 16, that is the root of 21. And substitute the values. Therefore, the required distance is a, this is the a bar dot n bar, that is a minus 7. The value of mod of n bar is a root of 21. The value of p is a 10. Substitute the values here. Therefore, you will get the required distance 17 upon root of 21 unit. Now the question number 21. That is, if e raised to x plus e raised to y is equals to e raised to x plus y, then show that dy by dx is equals to minus e raised to y minus x. Simple question. E raised to x plus e raised to y is equals to e raised to x plus y. Differentiate with respect to x. The derivative of e raised to x is e raised to x. Derivative of e raised to y is e raised to y into dy by dx. Derivative of e raised to x is e raised to x. Derivative of e raised to y is e raised to y into dy by dx is equals to derivative of e raised to x plus y. The derivative of e raised to x plus y is e raised to x plus y into, in bracket, derivative of x plus y. Therefore, see this here. Now the derivative of x is 1 and derivative of y is the dy by dx. Then collect the term of the dy by dx. This is implicit type of the derivative. Take the terms of the dy by dx on one side. That is e raised to y into dy by dx minus e raised to x plus y into dy by dx is equals to e raised to x plus y minus e raised to x. Take the dy by dx as a common. E raised to y minus e raised to x plus y into dy by dx is equals to e raised to x plus y minus e raised to x. Therefore, dy by dx is equals to e raised to x plus y minus e raised to x upon e raised to y minus e raised to x plus 1. Then substitute the value. That is e raised to x plus y means what? E raised to x plus e raised to y minus e raised to x. Then e raised to x plus and minus will get cancelled. And the next is e raised to y minus, in bracket, e raised to x plus e raised to y. And from the next term, that is e raised to y will get cancelled. Therefore, you will get, that is a minus e raised to y minus x. This is the dy by dx, and hence it is a proof. It is on the page number 17, unsolved question. Now see again the answer of this question. E raised to x plus e raised to y is equals to e raised to x plus y. Then show that dy by dx is equals to minus e raised to y minus x. Now differentiate this with respect to x. The derivative of e raised to x is e raised to x, e raised to y is e raised to y into dy by dx is equals to d dx of e raised to x plus y. Is e raised to x plus y into d dx of x plus y. Now the next is e raised to x plus e raised to y into dy by dx is equals to e raised to x plus y into derivative of x plus y. The derivative of x is 1 and y is a dy by dx. Multiply the term and simplify. That is, take the terms of the dy by dx on the left hand side. Take dy by dx as a common. Then dy by dx is equals to e raised to x plus y minus e raised to x upon e raised to y minus e raised to x plus y. Then substitute the value of e raised to x plus y. The value of e raised to x plus y is e raised to x plus e raised to y minus e raised to x upon e raised to y minus, in bracket, e raised to x plus e raised to y. Then the cancellation terms is e raised to y minus plus e raised to x and minus e raised to x get cancelled. Then you will get e raised to y. And from the denominator, e raised to y minus e raised to y get cancelled. You will get minus a raised to x. And by the exponent, by using the indices, minus e raised to y minus x. This is on the page number 70, unsolved question. Now the next question is on the page, that is question number 22. See this question here. That is question number 22. The surface area of a spherical balloon is increasing at the rate of, that is 2 centimeter square per second. At what rate the volume of the balloon is increasing when the radius of the balloon is 6 centimeter. It is on the page number 94 from the textbook. Now see this answer of this question. Question number 22, page number 94, unsolved question. It is also asked in the March 13 board exam. Let R be the radius of, radius S be the surface area and V be the volume of the spherical balloon. at any time t, then S is equals to the surface area, S is equals to 4 pi r square. Volume V is equals to 4 upon 3 pi r cube. Differentiate this with respect to t, we get ds upon dt is equals to, that is a 4 pi into 2r into dr upon dt. And next is, that is 8 pi r into dr upon dt. dv upon dt, that is a 4 upon 3 pi 3r square into dr upon dt, that is a 4 pi r square into dr upon dt. From 1, that is a dr upon dt, it is a 1 upon 8 pi r into ds upon dt. Therefore, 4 pi dr upon dt is equals to 1 upon 8 pi r into ds upon dt. dv upon dt is equals to 4 pi r square into 1 upon 8 pi r into ds upon dt. dv upon dt is equals to, that is a r upon 2 into ds upon dt. ds upon dt is a 2 centimeter square per second, and r is equals to 6 centimeter. Therefore, dv upon dt is equals to 6 upon 2. Substitute the value of r, which is 6 upon 2 into 2. That is, you will get 6. Hence, the volume of the spherical balloon is increasing at the rate of, that is a 6 centimeter cube per second. Now, see the second answer of this question. R be the radius, S be the surface area, and P be the volume of the spherical balloon. At any time t, then S is equals to surface area. This is the volume. Differentiate with respect to t, then ds upon dt, 4 pi, derivative of r square is a 2r into dr upon dt. And again here, that is a, simplify it, that is a 8 pi r into dr upon dt. This is one. The next is dv upon dt. Differentiate this v with respect to t. That is a dv upon dt is equals to 4 upon 3 pi 3r square into dr upon dt. That is a 4 pi r square into dr upon dt. Therefore, the value of dr upon dt from this one, that is a dr upon dt is equals to 1 upon 8 pi r into ds upon dt. Therefore, substitute the value here, dr upon dt. That is a dv upon dt is equals to 8 pi r square into dr upon dt, which is 1 upon 8 pi r into ds upon dt. Therefore, you will get dv upon dt is equals to r upon 2 into ds upon dt. But the value of the ds upon dt is given, that is a 2 centimeter square per second, and r is equals to 6. Substitute the value here. R is 6 upon 2, and here is a 2. Therefore, you will get the 6. Therefore, the final answer is, hence the volume of the spherical balloon is increasing at the rate of 6 centimeter cube per second. Now, the next question is, find the approximate value of e raised to 1.005, and given that e is equals to 2.7183. This on the page number 96, and it's solved question. Question number 23. Find the approximate value of e raised to 1.005 given that the value of e is a 2.7183. It's a solved question on page number 96. F of x is equals to, what type of the function is the exponential function? F of x is equals to e raised to x. What's its derivative? F dash of x is equals to, again, e raised to x. Therefore, a plus h is equals to 1.005. Here a is 1 and h is a 0.005. A is 1, h is 0.005. F of a plus h is equals to f of a plus h into f dash of a. F of 1.005 is approximately equal to f of 1 plus 0.005 into f dash of 1. Therefore, e raised to 1.005 is equals to, that is a e plus 0.005 into f dash of 1. That is the derivative of e raised to x is e raised to x. And again x is replaced by 1. Then overall you will get only the e here and substitute the value of e. That is e raised to 1.005 is equals to 2.7183 plus 0.005 into 2.7183. Make their multiplication. That is a 2.7183. The product is 0.013595. Add these two. Therefore, you will get 2.73189115. Let's see this again. The answer of this question. Find the approximate value of e raised to 1.005 given that e is equals to 2.7183. The solved question on the page number 96. F of x is equals to e raised to x. F dash of x is equals to e raised to x. The derivative of e raised to x is e raised to x. A plus h is equals to 1.005. That is 1 plus 0.005. A is 1, h is 0.005. F of a plus h is approximately equal to f of a plus h into f dash of a. Therefore, f of a plus h, that is 1.005, is approximately equal to f of 1 plus 0.005 into f dash of 1. Therefore, e raised to 1.005 is equals to e plus, that is a 0.005 into e. The value of e is a 2.7183 and their product is, that is a 0.013595 and the sum is e raised to 1.005 is equals to 2.7318915. Now the next question. Question number 24, that is evaluate the integration. It is from the integration x square into tan inverse of x cube upon 1 plus x raised to 6 into dx. Very simple question. Methods of substitution, that is the page number, it is on the page number 185. I is equals to integral x cube into tan inverse of, x square into tan inverse of x cube upon 1 plus x raised to 6 into dx. That is the tan inverse of x cube into tan inverse of x cube into x square upon 1 plus x raised to 6 into dx. Put tan inverse of x cube is equals to t. Their differentiation, derivative of tan inverse of x is 1 upon 1 plus x square. In the same manner, that is 1 upon x raised to 3 bracket square into ddx of x cube, that is a 3x square into dx is equals to dt. And therefore, x square into dx upon 1 plus x raised to 6 is equals to dt upon 3. Therefore, integral becomes, that is I is equals to t into dt upon 3. And its integration is very simple. 1 by 3 log of mod of t, that is log of t square upon 2 plus c. And you will get 1 by 6 t raised to, that is a tan inverse of x square x cube bracket raised to 2 plus c. This is the integration. It is on the page number 185 unsolved question. Now see this again, the solution of this. I is equals to integral x square dot tan inverse of x cube upon 1 plus x raised to 6 into dx. I is equals to integral tan inverse of x cube into x square upon 1 plus x raised to 6 into dx. Tan inverse of x cube is equals to t. It's a differentiate on both sides. That is 1 upon 1 plus x cube bracket square plus derivative of x cube is a 3x square into dx is equals to dt. Therefore, 1 upon x raised to 6 derivative of x cube is a 3x square into dx is equals to dt. Therefore, x square into dx upon 1 plus x raised to 6 is equals to dt upon 3. And that's why I is equals to integral t into dt upon 3. That is 1 by 3 t into dt. That is 1 by 3 t square upon 2 plus c. Substitute the value of t, that is the tan inverse of x cube bracket square plus c. It's on the page number 185 unsolved question. Now the next we'll see the next question. Question number 25. Now see this page first. The question. That is, solve the differential equation dy by dx plus y is equals to e raised to minus x. It is on the page number 272. Okay, solution on this. Dy by dx plus y is equals to e raised to minus x. This is the linear differential equation of the form dy by dx plus py is equals to q, where p is 1 if we compare it, and q is e raised to minus x. Integrating factor, that is equals to e raised to integral p dx. The value of p is 1, therefore it is e raised to x. If is e raised to x, multiply on both sides of the 1 by integrating factor, which is the e raised to x. That is e raised to x in bracket dy by dx plus y is equals to e raised to x into e raised to minus x. That is 1. E raised to x into dy by dx plus y into e raised to x, that is equals to 1. Therefore, dy by dx. Now, if you see this, this is nothing but the differentiation of e raised to x into y, that is equals to 1. That is e raised to x into dy by dx plus y into e raised to x, that is equals to 1. That is the ddx of e raised to x into y, that is equals to 1. Now, integrating on both sides, then you will get, now differentiating sign, this and integrating will get cancelled. Then you will get e raised to x, that is e raised to x into y is equals to integral of 1 dx plus c. That is e raised to x into y. The integration of this 1 dx is x plus c. Therefore, y is equals to x plus c into e raised to minus x. This is the general solution. Now again see this again here. Dy by dx plus y is equals to e raised to minus x. This is the linear differential equation. If we compare it with dy by dx plus py is equals to q, where p is equals to 1, q is equals to e raised to minus x. Integrating factor, that is e raised to integral p dx is equals to e raised to 1 dx, that is equals to e raised to x. Therefore, if is e raised to x. Multiply on both sides of the equation. 1 multiplied with this here. That is e raised to x in bracket dy by dx plus y is equals to e raised to x into e raised to minus x, that is equals to 1. If you multiplied it, then you will get e raised to x into dy by dx plus y into e raised to x is equals to 1. Now this is nothing but the differentiation of the e raised to x into y, that is equals to 1. Now integrate on the both sides, then you will get differentiation sign and the integrating get cancelled. You will get e raised to x into y is equals to integral of 1 dx plus c. That is integral of 1 dx. That is integral of dx is x plus c. Therefore, y is equals to multiply on both sides by e raised to minus x. Therefore, y is equals to x plus c into e raised to minus x. This is the general solution. Now, the next question. That is the question number 26. If f of x is equals to kx, the value of x lies between 0 to 2, otherwise it is a 0. Is the probability density function of a random variable x, then find the value of k and find the probability where x lies between 1 to 2. Very simple question. We have seen the f of x is the probability density function. Its integral 0 to 2 f of x, that is equals to 1. Therefore, integral of kx 0 to 2 kx into dx is equals to 1. Integrating, that is a k x square upon 2. Lower limit is 0, upper limit is 2. Substitute the value. Therefore, 2 raised to 2 upon 2 minus 0. That is a k into 2. Therefore, k is equals to 1 upon 2. Thus, the function is written as, it's f of x is equals to kx, but the value of k is 1 upon 2. Therefore, the function becomes f of x is equals to x upon 2. And the value of x lies between 0 to 2. Now, what is our question? Now, find the probability where x lies between 1 to 2. That is 1 to 2 f of x into dx. 1 to 2 x upon 2 into dx, 1 upon 2, 1 to 2 x dx. That is x square upon 2, 1 to 2. Substitute the value of 2 square upon 2 minus 1 square upon 2. That is 1 upon 2. This is the 2 square means for 2 minus 1 upon 2. That is equals to 1 upon 2, 3 by into 3 by 2. That is equals to 3 by 4. Hence, a probability where the x lies between 1 to 2 is equals to 3 by 4. This is the solved question on the page number 322. Now, see this again here. We have, since f of x is a PDF probability density function, 0 to 2 f of x into dx is 1, 0 to 2 kx into dx is 1. The integral of, that is a k is here, integral of x is x square upon 2, 0 to 2. That is a k into 2 square upon 2 minus 0. That is a k into 2 is equals to 1, k is equals to 1 upon 2. Thus, the f of x is equals to x upon 2, where the value of x lies between 0 to 2. And next is the probability of x, where x lies between 1 to 2. That is 1 to 2 f of x into dx. That is equals to 1 to 2 x upon 2 into dx. 1 upon 2, 1 to 2 x into dx, which is x square upon 2. That is 1 upon 2 into 2 square upon 2 minus 1 upon 2. That is 1 upon 2 into 2 minus 1 upon 2. That is 1 upon 2 into 3 by 2. That is equals to 3 by 4. This is on the page number 322 and it is a solved question. Now the next is, we'll see the next section D is there now. Section D, attempt any 5 of the following questions. 20 marks is there. Now the question is, let us see this question. Attempt any 5 of the following questions. Prove that a homogeneous equation of degree 2 in x and y, that is ax square plus 2hxy plus by square is equals to 0, represent a pair of lines passing through the origin if hs square minus ab is greater than or equal to 0. Now see this here. A homogeneous equation of degree 2 in x and y, that is ax square plus 2hxy plus by square is equals to 0, represents a pair of lines through the origin if h square minus ab is greater than or equal to 0. Now consider homogeneous equation of degree 2 in x and y. Ax square plus 2hxy plus by square is equals to 0. This is first. In this equation, it's a theory question. It is on the page number 116 in the text from the textbook. In this equation, at least one of the coefficient a, b or h is non-zero. That we consider the two cases here. If the b is equals to 0, then the equation becomes ax square plus 2hxy is equals to 0. Take x as common, then you will get here ax plus 2hy is equals to 0. It means x is equal, this is the joint equation of pair of two straight line passes through the origin, that is x is equals to 0, ax plus 2hy is equals to 0. These lines pass through the origin, case 2, b is not equals to 0, multiply on both sides by b, from the equation 1, then you will get abx square 2hxyb plus b square y square is equals to 0. That is b square y square plus 2hx. I am separating these terms into by is equals to minus abx square. To make the LHS a complete square, that is, we add on both sides h square x square. This is the first term. So by is here. This is the second term. That's why to make the complete square, the left hand side h square x square must be added there on the both sides. That is b square y square plus 2hx into by plus h square x square minus ab x square plus h square x square. Then you will get by plus hx. This is the perfect square of the by plus hx bracket square is equals to h square minus ab bracket complete into x square. That is by plus hx bracket square is equals to. Now this can be written as in root of h square minus ab into x and whole bracket square. Now see this again here. It is of the form a square minus b square, that is by plus hx plus in root of h square minus ab into x. In second bracket by plus hx minus in root of h square minus ab into x bracket complete equals to 0. It is a joint equation of two lines by plus hx plus in root of h square minus ab into x equals to 0 and by plus hx minus in root of h square minus ab into x is equals to 0. Therefore, again it can be written as h plus in root of h square minus ab bracket complete into x plus by is equals to 0 and h minus in root of h square minus ab bracket complete into x plus by is equals to 0. This line passes through the origin from above two. That is, from the above two cases we conclude that the equation ax square plus 2hxy plus by square is equals to 0 represents a pair of lines passing through the origin. Now also you can see this here. This is theory questions which is on the page number 116. Now the next is a question number 28. Solve the following linear programming problem. Maximize z is equals to 150x plus 250y. Subject to 4x plus y less than or equal to 40. 3x plus 2y less than or equal to 60. X is greater than or equal to 0. Y is greater than or equal to 0. It's on the page number 209. Now see this solution. Consider the LPP is formulated. Solved question is this. Maximize z is equals to 150x plus 250y subject to 4x plus y less than or equal to 40, 3x plus 2y less than or equal to 60, x is greater than or equal to 0, y is greater than or equal to 0. Let us represent the first two constant. For that, we convert the equations. For that, converts the inequations into equations. 4x plus y is equals to 40. Divide on both sides by 40. That is a 4x upon 10 plus y upon 40 is equals to 1. 3x plus 2y is equals to 60. Divide on both sides by 60. 3x upon 60 plus 2y upon 60 is equals to 60 upon 60. That x upon 20 plus y upon 30 is equals to 1. The region of the given constant shaded. Now see this x-axis, y-axis. The point A is 10, 0. C is 0, 30. This is the line 3x plus 2y is equals to 60. Next line is 4x plus y is equals to 40. The point of intersection. Solve it simultaneously. That is 4x plus y. That is you will get x is equals to 4. Put x is equals to 4. Then you will get y is equals to 24. This is the point of intersection. Then you will get the feasible region. This is the shaded region. The points are A 0, 0. Next is A 10, 0. B 2, 24. C is 0, 30, A is 1, 0. Now find out the value of C. Maximize, that is Z is equals to 150x plus 250y. At 0, we have 0. At A, 10, 0. Then you will get 1500, 1500. B, 424, that is 150 plus 150 into 4 plus 250 into 24, that is 600 plus 6000, that is 6600. At C, 150 into 0 plus 250 into 30, that is 7500. Z is the maximum when x is 0 and y is 30. Now see this again here. Maximize, these are the equations. Let us represent the first two constraints graphically. For that we convert the inequation to the equations. 4x plus y is equals to 40, 3x plus 2y is equals to 60. Divide on both sides by 40, x upon 10 plus y upon 40 is equals to 1. 3x upon 60 plus 2y upon 60, 60 upon 60. The region of the given constant is shown here. These are the points B, A. Okay. Now substitute the value of this is the 0. Next is A is a 10, 0. B is a 4, 24. C is a 0, 30. Maximize at the 0 it is 0. A is a 1500. At B it is a 6600. And at the C it is a 7500. Therefore Z is the maximum when x is equals to 0 and y is equals to 30. Solve the following equations by method of reduction. X plus 3y plus 3z is equals to 12. X plus 4y plus 4z is equals to 15. X plus 3y plus 4z is equals to 13 by using the reduction method. It is on the page number 58 and it is a solved question which is asked in the last question. It is for the 4 marks. Solve the following equations by the method of reduction. X plus 3y plus 3z is equals to 12. X plus 4y plus 4z is equals to 15. X plus 3y plus 4z is equals to 13. The above equations can be written in the, that is ax plus b is equals to 0. That is 133, 144, 134 x, y, z, and their constant, that is 12, 15, 13. Now using the R2 minus R1, that is a R2 minus R1 and R3 minus R1. Therefore, you will get 133 and x, y, z. 12, 3, 1. Now as A is a radius 2 and upper triangular, now their multiplication, that is the first row, first column, it will become x plus 3y plus 3z is equals to 12. What about here? 0x, that will become 0. Y plus z is equals to 3. And the last is 0x plus 0y plus 1z, that is equals to 1. And therefore, we rewrite the equations in the original form as x plus 3y plus 3z is equals to 12, y plus z is equals to 3, z is equals to 1. Substitute the value of z is equals to 1 here. Then you will get y is equals to 3 minus 1, which is equals to 2. And these are the three equations. Substitute the value of z, then you will get y. Next is 3x plus 3y plus 3z is equals to 12. Substitute the value of y and z, then you will get the value of x, that is equals to 3. This is 3. Hence, the required solution is x is equals to 3, y is 2, and z is 1. It is on the page number 51, and it is a solved questions from the textbook. Now see this here. These are the equations. It is in the form ax plus b. Only by using the single, that is this operation, that R2 changes R2 minus R1, R3 changes R3 minus R1. A is reduced to the upper triangular matrix. We write like this: x plus 3y plus 3z is equals to 12, x plus y plus z is equals to 3, and z is equals to 1. Substitute the value of z, you will get y. Substitute the value of y and z, you will get x. Now the next question is, in triangle ABC, a plus b plus c is equals to 2s. Then prove that sine of a by 2 is equals to in root of s minus b into s minus c upon bc with the usual notation. It is a solved question. Page number solved theory is there. That is question number 30. In triangle ABC, a plus b plus c is equals to 2s. Then prove that sine of a by 2 is equals to in root of s minus b into s minus c upon b into c. It's page number 86. Solved theory. This is solved theory. That is, we know that 1 minus cos of a is equals to 2 sine square a by 2. Therefore, by the cosine rule, we get 1 minus b square plus c square minus a square upon 2bc is equals to 2 sine square a by 2. Therefore, 2bc minus, if we simplify this, that is a 2bc into 1, then you will get 2bc minus b square minus c square plus a square upon 2bc is equals to 2 sine square a by 2. Therefore, a square in bracket b square minus 2bc plus c square upon 2bc. If we simplify this, then a square, take the minus sign common from these first three terms, then minus in bracket b square minus 2bc plus c square upon 2bc is equals to 2 sine square a by 2. That is a square minus in bracket b minus c bracket square upon 2bc is equals to 2 sine square a by 2. Therefore, you will get a plus b minus c in first bracket. Second bracket is a minus b plus c upon 2bc is equals to 2 sine square a by 2. Therefore, a plus b plus c minus 2c. That is here, plus c is here, then you will get minus 2c. Here is a plus b plus c, that is a minus 2b will be here upon 2bc. That is a 2 sine square a by 2. Therefore, what is a plus b plus c? It is a 2s minus 2c. This is again 2s minus 2b upon 2bc. Therefore, 2 sine square a by 2. That is s minus c into s minus b upon bc. That is sine square a by 2. Therefore, sine of a by 2 is equals to, take the square root on both sides. Then you will get s minus b into s minus c upon bc. And this is, that is the, as sine of a by 2 is the acute angle and it is a positive. Therefore, sine of a by 2 is equals to in root of s minus b into s minus c. Now then you can see this, the solution of this It is 1 minus cos A, 2 sin square A by 2. Substitute the value of cos of A. Simplify this. That is 2bc minus b square minus c square plus a square upon 2bc is equals to 2 sin square A by 2. A square minus in bracket b square minus 2bc plus c square upon 2bc is equals to 2 sin square A by 2. Now here is a b minus c bracket square a square minus in bracket b minus c bracket square upon 2bc is equals to 2 sin square A by 2. That a plus b minus c second bracket a minus b plus c upon 2bc is equals to 2 sin square A by 2. Therefore, here is again add the term plus c minus c, a plus b plus c minus 2c, a plus b plus c minus 2b, add b minus b. Therefore, we will get the sine of A by 2, take the square root on both sides. Now the next is, this is a question from the limits and continuity. It's very short example. That is, a function f of x is a continuous on the closed interval minus 2 to 2. Here f of x is equals to sine of ax upon x plus 2. The value of x lies between minus 2 to 0. F of x is equals to 3x plus 5. For the values of x, this lies between 0 to 1, equal to 0, equal to 1. And f of x is equals to in root of x square plus 8 minus b. For x lies between 1 and 2 and equal to 2. Then find the value of a plus b plus 2. Now, see this here. Very interesting problem. The given function breaks at the 2 points, at the 0 and at 1. The function is a continuous on its domain minus 2 to plus 2. F of x is equals to sine of ax upon x plus 2. Now see this here, the given function breaks at the point 0 and 1. Therefore, find the value of a plus b plus 2. Since the function f of x is a continuous on the domain minus 2 to plus 2, it is a continuous at x is equals to 0, x is equals to 1. As f of x is a continuous at x is equals to, the given function breaks at the 2 points, that is at 0 and the 1. And therefore, we will find out the left hand side limit and right hand side limit at these 2 points. And then we will get the value of a plus b plus 2. That is the limit x tends to right hand side limit f of 0, left hand side limit. That is it. We take the function sine of ax upon x plus 2. A is adjusted there to the numerator and the denominator. Therefore, a plus 2, this is the left hand side limit. Now for the right hand side limit, we take the function 3x plus 5. 3 into 0, that is equals to 5. F of 0 is equals to 5. And therefore, a plus 2 is equals to 5 and the value of a is equals to 3. Also, the continuity at the point x is equals to 1. For that, we take the left hand side limit for the function 3x plus 5 and the right hand side in root of x square plus 8 minus b. Therefore, left hand side limit, the function is 3x plus 5, replace x by 1, 3 into 1 plus 5, that is equals to 8. f of 1, that is 3 into 1 plus 5, that is equals to 8. And the limit x tends to 1 plus f of x, then that is it. For the right hand side limit, we take the function in root of x square plus 8 minus in root of x square plus 8 minus b, in root of 1 plus 8, 9, that is a 3 minus b. Therefore, the 3 minus 8 is equals to b is equals to minus 5. And that's why a plus b plus 2, that is a 3 plus minus 5 plus 2, that is equals to 0. Therefore, a plus b plus 2 is equals to 0. Hence, the result. That is a value. That is a plus b plus 2 is equals to 0. Now, see this again. The given function breaks at the point 0 and the 1. We'll find out the left hand side limit for the 0, right hand side limit. At the point 1, this is the left hand side limit. At the point 1, this is the right hand side limit. Now see this. Since the function f of x is a continuous on the domain minus 2 to, is a continuous at x is equals to 0 and x is equals to 1. As f of x is a continuous at x is equals to 0, limit x tends to left hand side limit of f of x as x tends to 0, limit x tends to 0, right hand side limit f of 0. For x is less than 0, that is the left hand side limit, the function is sine of ax upon x plus 2, adjust a, then you will get a plus 2. X is greater than or equal to 0, that is a 3x plus 5, then you will get 5. That is a plus 2 is equals to 5 because these two are equal. Therefore, a is equals to 3. As f of x is continuous at x is equals to 1, left limit, right limit, f of 1, limit x tends to left hand side limit, that is a 3x plus 1, this is the function which is equals to 8, f of 1, that is equals to 8. Right hand side limit, limit x tends to 1 plus, that is the right hand side limit in root of x square plus 8 minus b, and you will get 3 minus b. Again 3 minus b is equals to 8. Therefore, b is equals to minus 5, a plus b plus 2. The value of a is 3, value of b is minus 5 and plus 2. And overall it becomes 0. Therefore, a plus b plus 2 is equals to 0 and hence the result. Now next is this is the theory questions from the integration, very famous theory, that is in root of integral in root of x square plus a square into dx is equals to x upon 2 in root of x square plus a square upon 2 log of mod of x plus in root of x square plus a square plus c. This theory bit will solve by using the integration by parts, that is integral in root of x square plus a square 1 dot dx is equals to dx. That is integrating by parts, first function into integral of the second minus integral ddx of the first into integral of the second function. Now here root of x square plus a square is the first function, 1 is the second function. I is equals to in root of x square plus a square integral 1 dx minus integral derivative of ddx of in root of x square plus a square dot integral of 1 dx. The integral of 1 is x and integral of 1 is also here x, and we want to find out the derivative of in root of x square plus a square, that is in root of x square plus a square, integral of 1 is x, integral derivative of in root of x square plus a square, that is 1 upon 2 in root of x square plus a square into ddx of x square plus a square. The derivative of x square is a 2x, a square is a 0, integral of this 1 is x, Therefore, x in root of x square plus a square minus x square plus a square minus, that is x in root of x square plus a square minus integral x square plus a square minus a square upon in root of x square plus a square into dx. Separate it. That is x square plus a square. If we separate this, that is a x square plus a square divided by root of x square plus a square minus a square upon in root of x square plus a square. Then if we evaluate it, then you will get x in root of x square plus a square minus and plus. This minus minus will become plus. Now this is nothing but the again I. X in root of x square plus a square minus I plus a square in integral dx upon in root of x square plus a square. This minus I will become plus I to the left hand side. That is nothing but the 2I. X into in root of x square minus a square plus a square log of mod of x plus in root of x square plus a square plus. This is the C1. Now divide on both sides. That is a 2I. That is x in root of x square plus a square divided by 2. That is a C1 upon 2. And to the next step, it is replaced by like this a square upon 2 log of mod of, where C is equals to C1 upon 2. Also, you can see this here also. This is a theory bit. That is I is equals to integral in root of x square plus a square 1 dx, integrating by parts. First function into integral of the second minus integral derivative of the first into integral of the second. It's a derivative 2x upon in root of 2 in under root of x square plus a square. Integral of 1 is x. Evaluate, cancel it. X square plus a square minus a square. A square is adjusted there. Split up it, separate it. X square plus a square divided by root of x square plus a square. It becomes minus integral in root of x square plus a square minus a square upon in root of x square plus a square. This minus minus will become plus. That is x in root of x square plus a square minus integral in root of x square plus a square dx plus integral a square upon in under root of x square plus a square dx. This is nothing but the minus I. That is it. When it comes to the left hand side, it becomes 2I. 2I is equals to x in root of x square plus a square log of mod of x plus in root of x square plus a square plus C1. Now divide on both sides by 2. Then you will get I is equals to x upon 2 in root of x square plus a square upon 2 log of mod of x plus in root of x square plus a square plus C1 upon 2. And this is nothing but the required formula. I is equals to x upon 2 in root of x square plus a square upon 2 log of mod of x plus in root of x square plus a square plus c, where c is equals to c1 upon 2. And now the next question. Question number 33. A fair coin is tossed 8 times. Find the probability that it shows no head. It shows head at least once. It is on the page number 336, which is the unsolved question. So this is very simple. A fair coin is tossed 8 times. Find the probability that it shows no head. It shows head at least once. Now see this here. Page number 336. Unsolved question. X is equals to the number of the heads. P is the probability of getting head. P is equals to 1 upon 2. Q is equals to 1 minus P. That is equals to 1 minus 1 upon 2 is equals to 1 upon 2. Q is equals to 1 upon 2. N is equals to 8. X follows the binomial distribution 8 and 1 upon 2. The mass function of X is given by the given as P of capital X is equals to the small x, P of X is equal to NCX, P raised to X, Q raised to N minus X, P of X is equals to 8Cx, 1 upon 2 raised to X and 1 upon 2 raised to 8 minus X, where X is equals to 0, 1, 2 up to 8. As it shows no head, therefore X is equals to 0. That is P of X 8Cx, 1 upon 2 raised to X, 1 upon 2 raised to 8 minus X. That is a 8C0, 1 upon 2 raised to 0, 1 upon 2 raised to 8 minus 0. Then the value of 8C0 is a 1. This is also 1. And 1 upon 2 raised to 8, which is a 256. That is P of 0 is equals to 1 upon 2 raised to 8. Now the next is getting it shows head at least once. That is a getting head at least once. That is a P of capital X greater than or equal to 1. That is nothing but 1 minus P of capital X is equals to 0. Now substitute 8C0, 1 upon 2 raised to 0, 1 upon 2 raised to 8 minus 0. This is 1 into 1, 1 upon 2 raised to 8. That is 1 upon 1 minus 1 upon 256. That is nothing but 255 upon 256. P of capital is greater than or equal to 1. This is nothing but 0.996. If we calculate it, then you will get the answer by using the log table. Hence, the probability of getting head at least once. Now the next is a very famous theory bit. That is again we will see this question, answer of this question. A fair coin is tossed 8 times. Find the probability that it shows no head. It shows head at least one. X is equals to the number of the heads. P the probability getting the head. P is equals to 1 upon 2. Q is equals to 1 minus P. That is 1 minus 1 upon 2 is equals to 1 upon 2. And Q is equals to 1 upon 2. N is equals to 8. X follows the binomial distribution 8 and 1 upon 2. The value of N and B. The probability mass function of X is given by the formula P of capital X is equals to the small x. P of X is equals to NCX, P raised to X, Q raised to N minus X. P of X is equals to 8Cx, 1 upon 2 raised to X, 1 upon 2 raised to 8 minus X, where X is equals to 0, 1, 2, up to the 8. It shows no head. That X is equals to 0. Substitute X is equals to 8Cx, 1 upon 2 raised to X, 1 upon 2 raised to 8 minus X. P of 0, 8C0, 1 upon 2 raised to 0, 1 upon 2 raised to 8 minus 0. This is 1, 1, 1 upon 2 raised to 8. That is P of 0 is equals to 1 upon 2 raised to 8. That is equals to 1 upon 256. Getting head at least 1. That is the P of capital X is greater than or equal to 1. This is nothing but 1 minus P of capital X is equals to 0. 1 minus 8C0, 1 upon 2 raised to 0 and 1 upon 2 raised to 8 minus 0. And this is 1, 1, 1 upon 2 raised to 8. That is 1 minus 1 upon 256. If we evaluate it, then you will get P of capital X is greater than or equal to 1. That is nothing but 0.996, and the probability of getting the head at least once is 0.996. Now the next question, it is the theory bit again. That is integral 0 to 2a. Integral 0 to 2 f of x into dx is equals to 0 to f of x into dx plus 0 to a f of 2a minus x dx. Now consider the RHS. 0 to f of x dx plus 0 to a f of 2a minus x into dx. This is I1 and I2. For I2, that I1 is as it is, it has no problem. We'll solve the I2. I2 is equals to integral 0 to a f of 2a minus x into dx. Put 2a minus x is equals to t. Therefore, differentiate this. Minus dx is equals to dt. Therefore, dx is equals to minus dt. When x is equals to 0, 2a minus x, that is t is equals to 2a. And when x is equals to a, then t is equals to a. And therefore, integral 0 to a f of 2a minus x into dx is equals to 2a, that is a 2a integral. Lower limit is 2a, upper limit is a f of t into minus dt. Then you will have the minus sign, that is f of t into dt. Absorb the negative sign, a to 2a f of t into dt. That is by using the property. Therefore, 0 to a f of 2a minus x is equals to, that is using the property of the change in the variable, and this is the minus sign. If you change the upper limit and lower limit, it gets the minus sign. I1 plus I2 is 0 to a f of x into dx plus a to 2a f of x into dx. That is, this is nothing but 0 to a f of x into dx, a to 2a f of x into dx. This is nothing but 0 to 2a f of x into dx, and this is our LHS. Hence, LHS is equals to RHS, and therefore integral 0 to 2 f of x into dx is equals to 0 to a f of x into dx plus 0 to a f of 2a minus x into dx. And in this way, I had solved all the paper board from the board exam, which was held on the 28th of the February. I hope that you will understood whatever that I had explained. Now we'll see in the next video. Till then, goodbye.